Alright, so to measure frequency response, we take a function generator along with an oscilloscope, and we put the function generator input on our signal input for the amp, and channel 1, which is the yellow, also connects to our signal input for the amp as well. This is going to send in a sine wave, and based off the difference in amplitude between the first channel and the second channel is going to tell us our gain, which is how much the amplifier amplifies the signal. The second channel cord runs from here to this power resistor we have there that acts as the speaker. Once we plot out our frequencies from 20 hertz all the way up to 20,000, we plot this data on our chart here. We see voltage in, which is the yellow, is about 264 millivolts. Voltage out on channel 2 is 6 volts. This gives us a gain of, we're going to use 1,000 as a reference point. That gives us a gain of 23, which means the input signal is multiplied 23 times. It's 23 times more powerful on the way out than it is on the way in. We convert that to decibels, which is 20 times log base 10, which shows us our loudness there. And then what I did is, based off of a reference, 1,000 hertz, we see how much it falls outside of the standard deviation. Typically in commercial audio stuff, 2 decibels falls within 1 standard deviation. For us, our largest is 1.4, and then down here we see it's even less on the high range. So you would say that this has a flat rate response from 20 hertz to 20,000 hertz, plus or minus 2 decibels. That is for the black market there. And if you look, this should be a plateau, more or less it is, because it falls under the 1 standard deviation, which is what we've seen up here. I know you see 4s here, but if you look at the negative to the -6, that's actually 5 zeros in front of that 4 right there. But for the most part, we have a flat rate response. This is really good. I stopped taking measurements at 20,000 because there's no point of us to going past that when it comes to, you know, what's considered an audible audio range. So there you go.